All right, for today's lesson, you'll be doing lesson 12 of topic B for module 4. By the end of this lesson, you're going to be able to represent a proportional relationship in a table and an equation in standard form. You'll learn what that is today. You'll know you're successful when you can take a word problem, create an equation in standard form, and then use that equation to fill out a table and then create a graph. We're going to review some things together, do some examples, exercises, and then you'll do your exit ticket. All right, for the opening exercise here, I just want you to watch me as I model what you're going to be doing today. So today you're going to be learning about a new way to write equations, and the format is called standard form. And I'm just going to go ahead and start this. It says, Emily tells you that she scored 32 points in a basketball game. It's a lot of points. It says, write down all the possible ways she could have scored 32 with only 2 and 3-point baskets. Use the table below to organize your work. So, we're just going to get started here. I'm going to go ahead and fill this in with one number. I'm going to say, okay, let's say she got one 2-pointer. So one 2-pointer is worth 2 points, right? And she scored a total of 32 points. So that means there's 30 points left that have to be made for her to have that 32 points. So how many 3-pointers would she need to get 30 points? She would need 10. So this is one way she could have made 32 points, right? She could have done 10 3-pointers, got 30 points from that, and then one 2-pointer and got 2 points from that, okay? Now let's see if we could do 2. So let's say she did 2 2-pointers. That would be 4 points, right? And that would mean we have 28 points remaining. Now, will 3 go into 28 evenly? It's not going to, right? So this is not going to be a combination. We can't do 2 points. Okay? So let's try 3 2-pointers. So 3 2-pointers would be 6 points. All right? And from there, we would have how many remaining? Well, 32 take away 6. 26 points remaining. Is 3 going to go into that evenly? No, that's never going to work. So that's not an option. Well, what if we did 4 2-pointers? 4 2-pointers is going to get us 8 points. And if we do 32 take away 8 points, we're going to get 24. So we need a way to make 24 points. Is 3 going to go into 24? Yeah. 3 goes into 24 8 times. So if we had 4 2-pointers, that's 8 points. And 8 3-pointers, that's 24 points. So that adds up to equal 32. So I'm going to go ahead and I'm going to try 5. This would be 10 points. And we would need 22 points left. And 3 is not going to go into 22 evenly, so we cannot do this. I don't know why this is not working. There we go. All right. So let's try 6. That would give us 12 points here. That would mean we would have 20 points remaining. Again, 3 is not going to go into that, so we're going to undo those things. I'll try 7. This gives us 14 points. Well, 32 minus 14 is 18. And 3 does go into 18 evenly. 3 goes into 18 6 times. And I want to see if I can find a pattern here. I have 1, 4, 7. What's happening each time? Well, they're increasing by 3. So I'm going to try 10 right here. So 10 2-pointers is going to give me 20 points. Well, that would mean I would have 12 points left over here. And how many times does 3 go into 12? 4 times. So again, I see a pattern, and I'm just going to keep going with this pattern. Well, 3 more than 10 is 13. And 2 less than 4, I see it's going down by 2 each time on my right side. would be 2. Let's see if this works. Well, 13 times 2, this would be 26 points. And 3 times 2 would be 6. 26 plus 6, 26, 27, 28, 29, 30, 31, 32. That works. And I have one more here, so I'm going to try 16 and 0. So 16 times 2 is 32 points. And over here, no 3-pointers, 0 points. So I have filled out my table. And this is just kind of to give you an idea of why we're going to be writing the types of equations we're writing, because there's a way easier way to go about solving this, all right? And I did a lot of guessing and checking, and there's a mathematical process that you could use to do this, and you could do it by writing an equation. So at the bottom it says, let x be the number of 2-pointers. So let x be the number of 2-pointers, and y be the number of 3-pointers, and we scored. Write an equation to represent the situation. So we know that the 2-pointers are x, the 3-pointers are y. And together, when we add these up, it equals 32. But there's something I'm missing from here. Each 2-pointer is worth how many points? Well, each 2-pointer is worth 2 points. So 2 times x is going to be part of my equation. And each 3-pointer is worth 3 points. So this is how my equation is going to look. 2x plus 3y equals 32. From there, we could just plug numbers in for x and y and solve for the other variable to figure out how many points would work. And I did this in my head up top. I just did not do it mathematically, which would have saved me a lot of time. But this is my equation. So today we're going to be writing equations and using equations like this to fill out our table. This is called standard form. Okay, and the standard form follows this format. Something times x, a times x, plus b times y equals c. We say c, but like whatever they give us it to equal, but this is the format. So you will actually be figuring out what goes for A, what goes for B, and what goes for C. In our case, our A was a 2, our B was a 3, and our C was 32. And if this is confusing for you right now, I promise you it's not going to be when we actually get into this work, all right? You're going to get really used to standard form. All right, for this first worked example that you're going to do with me, it says find 5 solutions to the linear equation x plus y equals 3 and plot the solutions as points on a coordinate plane. So here we're just going to be solving this equation, plugging numbers in and seeing if they work out. So if you can notice, this equation is written in standard form. We have the format ax plus by equals c. One thing to notice though here, there's no coefficient for our x and y's. So this is just like 1x plus 1y equals 3, okay? So we're going to plug these things in. So it's basically saying something plus something equals 3. Well, what if the x was a 1? Then this would become 1 plus y equals 3. Well, what would y be to make the answer 3? 1 plus what equals 3? Well, you can do that in your head. 1 plus 2 equals 3. Okay? Now what if x is a 2? 2 plus y equals 3. Well, if x is a 2, 2 plus what equals 3? A 1. Y would have to be 1. All right. Now let's try 3. If x is a 3, 3 plus what equals 3? Y is going to have to be 0. All right? And you might think, well, that's all the numbers that I have. But what if x is a 4? 4 plus what equals 3? You're like, well, that doesn't make sense. You can't add anything to 4 to get 3. But you can. You can add a negative 1, right? 4 plus negative 1 does equal 3. let's just do 5. 5 plus what equals 3? Well, you'd have to kind of go backwards, so this would be plus negative 2. All right, so I filled out my table using my standard form equation. Now I'm going to graph this. So here are your ordered pairs. You have your x and your y. So we first are going to graph 1, 2. Then we're going to graph 2, 1. And then 3, 0, 4, negative 1. And 5, negative 2. Remember that our ordered pairs always have our x value first, our y value second, and they follow this format. Our x tells us which way to go over, our y tells us which way to go up. All right, starting with 1, 2, I'm going to go over 1, up 2. That's my first little point. Then I'm going to go over 2, up 1. Then I'm going to go over 3, up 0. Then I'm going to go over 4, negative 1, over 5, negative 2, or down 2. So this is the line that I've created. You can see that this is linear, it's a straight line, and we'll also get into this later, but this is a negative slope. And we're done here. Example 2, we're going to do the exact same thing. You can see that we have this equation. It's written in the form ax, our a in this case is a 2, plus by. Our b in this case is a, let me zoom in real quick, negative 1. Okay, I changed that to plus sign to follow my format. So our b in this case is a negative 1. And our c in this case is a 10. All right, so we're going to go ahead and try to work this out. This one's a little bit more confusing for us, but we're going to do the exact same process. So I'm going to say, what if x was a 1? What would that mean? Y would have to be. I'm going to actually zoom in too so I have more room to work. So I'm changing this x to a 1. And I'm going to solve for y. So 2 times 1 is 2. So 2 take away y equals 10. And I'm just going to solve for that y. Well, first I'm going to change this to plus negative. So this becomes plus negative y, or negative 1y, whatever you want to do. And then I'm going to try to solve for that. So I'm going to take 2 away from both sides. So this becomes negative y equals 8. And again, I just took 2 away from both sides. But I don't want a negative y, I want a positive y. So I'm going to have to divide by negative 1 on both sides. And when I do that, this becomes positive y equals negative 8. So when x is 1, y is a negative 8. Okay? Now I'm going to try when x is 2. So this becomes 2 times 2 minus y equals 10. Well, 2 times 2 is 4. So 4 take away y equals 10. 4 minus something equals 10. Well, I can't do this yet. I can't solve for y until I change this to plus sign. From there, I'm going to take away that 4. So this becomes negative y equals, what's 10 take away 4? 6. But I don't want a negative y, I want a positive y. So I'll have to divide by my negative 1. And this becomes y equals negative 6. So when x is 2, y is negative 6. And you're kind of starting to see a pattern develop. I'm going to just, instead of going to 3, I'm going to skip to 5. So 2 times 5 minus y equals 10. What's 2 times 5? 10. Now I can do this in my head. 10 take away something equals 10. Well, the only thing that it can take away to stay 10 is 0. So y equals 0. All right, I'm going to go with 6. So 2 times 6 minus y equals 10. Well, 2 times 6 is 12. 12 take away y equals 10. 12 take away what equals 10? Well, 12 take away 2 equals 10. And we have to find one more value here. I don't care what you use. I'm just going to go ahead and skip to 10. Don't know why I just chose 10. 2 times 10 minus y equals 10. Well, 2 times 10 is 20. So 20 minus something equals 10. What would that something be? 20 minus 10 equals 10. So I have my ordered pairs here, right? I have 1, -8, 2, -6, 5, 0, 6, 2, and 10, 10. All right, so I'm going to just go ahead and plot them real quick. So I'm going to go over 1, down 8. 1, 2, 3, 4, 5, 6, 7, 8. Got that one. I'm going to go over 2. 1, 2, down 6. 1, 2, 3, 4, 5, 6. I'm going to go over 5, up 0. 1, 2, 3, 4, 5. Up 0, so it's just going to stay right there on the x-axis. I'm going to go over 6, up 2. 1, 2. And then I'm going to go over 10, up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you'll notice that my numbers are spaced out because I didn't do like 1, 2, 3, 4, 5. I did 1, 2, 5, 6, 10. But this still creates a linear equation when I graph it. And I am done with this example. All right, for this one, I want you to go ahead and give it a try on your own. Choose any value for x, plug it in, and then solve for your y. When you're done, please graph your equation. I'm going to give you about 5 minutes to try this on your own, and then we will check our work together. All right, I've gone ahead and I've plugged in some random numbers for x. I just want to go ahead and let you guys know that we probably did not choose all of the same numbers, and that is completely fine. All right? There's no need to be crazy about, the numbers that we chose, because no matter what numbers we chose, if we did our math right, our line is going to look the same. So your line should look like mine. It should be going kind of at this small slope, kind of like a negative slope that's not that super steep or anything. But the values that you plugged in, you should have been able to find a corresponding value. A lot of mine were, fractions that I turned into decimals because it's easier for me to graph decimals. And it's kind of hard to graph, something that's not exactly an even increment or a whole number. We just kind of, do our best to figure out where that is. But this is what the graph should look like. So your graph should look similar to that. Your line should be at that same place. Okay? All right, this one's a little bit longer. It says, at the store, you see that you can buy a bag of candy for $2 and a drink for $1. Assume that you have a total of $35 to spend. You're feeling generous and you want to buy some snacks for your friends. Write an equation in standard form to represent the number of bags of candy, X, and the number of drinks you can buy with $35. So this is what we're going to do real quick. We're going to write our equation in this format. Ready? AX plus BY equals C. So a few things we need to figure out are what is A, what is B, and what is C. Now we know that C is probably going to be our total, right? Our total of $35 that we have. So it's going to equal 35. But what things are we adding? What is going to be our A? What is going to be our B? Well, it says that our candy is $2 and our drink is $1. So these are the numbers that are going to go here. So we spend $2 on one bag of candy, but we don't know how many, $2 on a drink. We don't know how many drinks we can buy. And we spend $1. Oh my gosh. No, I had that right at the beginning. We spend $2 on a bag of candy, and we don't know how many bags of candy we can buy, and $1 on each drink. We don't know how many drinks we can buy, but we know we have a total of $35 to spend. So this is the equation that we would write here. Okay? So using this equation, I want you to go through this table and figure out the different combinations of, bags of candy and drinks you could buy. I'm going to start you off with the first row, and then I want you to find the remaining 4 rows, okay? So let's just say X is a 1. It's pretty much the easiest number to start with. So this becomes 2 times 1 plus 1y equals 35. And I'm just going to solve for y. I want to know what y equals. So this becomes 2 plus 1y equals 35. Well, how am I going to get this y by itself? I'm going to subtract by 2, subtract by 2, I get y equals 35 minus 2, which is 33. So if I only bought one bag of candy, I would only spend $2, and then I have $33 left. I can get 33 drinks because they're each $1. Now, the numbers that you plug in here, I just want you to list off to the side, show your work in the middle, and then tell me what y is going to equal. I'm going to pause this video, and then I'm going to give you some time to fill out your table on your own. All right, so I went ahead and filled out my table. I chose the x variables to be 1, 2, 10, 12, and 13. You could have chose completely different numbers than I did. Because my numbers are so big, like I have 33, 31, 15, 13, I don't have that much space on my graph. So I'm not going to necessarily graph those numbers. I think I could probably try to graph these ones down here because they're a little bit smaller, and I could maybe stretch out my table a little bit more to graph them. So I'm just going to graph 2 points. I'm going to do the first one over 10, up 15, 10, 11, 12, 13, 14, 15. So it's going to be like, the point's going to be like way off the graph, like up here. The next one was over 12. So 10, 11, 12, up 11. So it's going to be like right here. So my line is going to be like way off this graph. If this graph was, oh, I did that terribly. If this graph was a lot bigger, I could probably put this on here, but I can't. This is just kind of getting you used to plugging these variables in. And what does this mean? Well, this table means that if I had 13 bags of candy, I would have $9 left, and I could spend $9 on 9 drinks because they're each $1. If I bought 12 bags of candy, I could buy 11 drinks, and I would be able to do that with the money I started with, etc. Okay? All right, this is your exit ticket for today. I'm going to do number 1 with you, and then you're going to do number 2. So it says, is the point 1, 3 a solution to the linear equation? So remember, this is my x, and this is my y. So it's basically saying when x is a 1, so I'm going to fill this in. When x is a 1 and y is a 3, will it equal 32? Well, let's check it out and see. 5 times 1 is 5. 9 times 3 is 27. Is that going to equal 32? Well, I can tell you right now, 5 take away 27 is not going to equal 32, right? If I did 5 take away 27 in my calculator, I get negative 22. And negative 22 does not equal 32. So this coordinate pair right here is not a solution. It means it's not going to be on that line. So no, this is not a solution. Okay. Now from here, for the exit ticket portion of this, I want you guys to do number 2. It says find 3 solutions to this equation, and then graph them on the coordinate plane. You'll notice that the coordinate plane is blank. So this means like if, like in that last example where my numbers were super huge and off the charts, you can create this chart however you want so that you can fit your values in, okay? So go ahead, take some time, choose values for x, see what value for y corresponds with that value x, and then I just want you to plot 3 solutions on this coordinate plane, and that is your exit ticket for today.